MCR3U, we're on our second day looking at functions or not functions. First thing we want to define is what a relation is. A relation is, as it sounds, a relationship between two, there we go. Infinite problems tonight getting this recorded. Between two variables. For instance, you can have a relation between height and time. It's a relationship between how high the ball is after so many seconds. You can have a relation between cost and how many chocolate bars you purchase. A function is a bit more specific than that. A function is a relation with a rule that gives one single output for every input. For instance, if you buy 5 chocolate bars, there's not a choice of cost. It's $2. It's not $2 or $10. There's only one answer when you buy 5 chocolate bars. At 3 seconds, the ball will be at 10 meters of height. There's not a couple possible answers. There is one output for every input. A function isn't a set of ordered pairs. We usually use x, y, in which for every x, there is one y. We're going to use the expressions domain and range much more in depth come Friday, but I wouldn't mind you having a written definition on this page. Your domain are your valid x values, your independent first elements in set. So for our height example, your domain would be the time. The valid time would not include negative time values. That doesn't make sense when you're talking about time. So the domain would be time that's positive. Your range is your valid y values. The dependent second elements in a set. The most helpful thing to remember domain and range. Domain is your x values, your range is your y values. Put that on hold till Friday. Let's have a look at the following two. Which of the following relations is a function? The first one is a function. We have all different x values, and they have exactly one corresponding y value in each case. The second one is not a function because when x is 5, your answer could be 3 or your answer could be 4. That is not a function. C is not a function either because when x is 2, y could be 4 or y could be 6. That is not a function. We have some examples and non-examples of functions and non-functions. This first one there. The first one is a function because a Civic can only be a Honda. An Accord can only have one answer, Honda. And the pilot can only have one answer, Honda. That is a function. The non-example would be the second one, because a Honda can be a Civic or an Accord. So because we are following the arrows left to right, because Honda maps onto two things, that is not a function. Second on the left. Each one of those values on the left, or our x or independent, is mapped onto one value on the right. -2 only goes over to 4. -1 only maps onto 1. 0 only maps onto 0, and so on. Each x has only one y value. This one is not a function because for 4 has an answer of -2 or 2. You can't have two answers and be a function. Bottom left is also a function. Each one of those map onto exactly one answer in the y. So for each x, there is one answer that corresponds to it. This one is not a function because 21 can have two possible solutions. It is not a function. Take a second, pause, have a look, and see which ones are functions and which ones aren't. Function, function, not, not. Here's some examples and non-examples, and this one has a boo-boo on it. Let's see if you can catch it. We're looking at tables of values. For every x, there should be one y value for it to be a function. This one is a function. There are 3 different x values that have unique answers in the y column. This one as well is a function. Each one of those x values has only one answer in the y column. Same with the third one. This one is not a function because the x value of 21 can have an answer of 0 or a 1. That is not a function. The second one down is a function. There are 4 different x values that each have one answer corresponding in the y column. That is actually a function. This one is not a function because we have 2 possible values for 0, and we have 2 possible answers when x is 3. That is profoundly not a function. Please pause, take a second, make sure you can catch which one of these are functions and which ones aren't. Function, function, not function, not function. From graphs, we can determine whether something is a function or not with the same principle. For this first one, top left, we want to find one y value for every x value to determine whether it's a function or not. So I'm looking where x is 2. When x is 2, we have exactly one answer on the function, right there. Let's pick another one. When x is -3, I have exactly one y value. When x is -3, my y value appears to be 0. That is a function. The one to the right of it is not a function. For instance, when x is -2, I have a possible y value here and a possible y value here. There are 2 y values for my x value. That is not a function. An easy way to figure out from a graph whether a relation is a function or not is to look at a vertical line. Fancy lingo, we call this the vertical line test. If a vertical line passes through a function and only hits it in one spot, it is a function. If it passes through your relation and hits it in 2 or more places, that is not a function. So for a function, any vertical line should hit it in only one place. Middle left is a function. That's a sine wave. And any vertical line that I put over that function will only touch in one spot. That is a function. The second one is not a function. If I put a vertical line there, well, sort of vertical, and or there, it would hit the function, the relation in two different places. That is not a function. Bottom left, we know parabolas. Parabolas are functions. Any vertical line that I were to place on that graph would only touch it in one place. It's a function. This is not a function. It's called a hyperbola. Any vertical line would touch it in two places, not a function. Pause for a second. Make sure you've got all four of those figured out as far as function or non-function goes. Not a function, 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 not a function. This is course note 22. It did not scan at all. But I would love for you to take a moment in your course notes, fill that Fryer diagram out completely with examples, definition, the rules, and non-examples. Copy them right out of the lesson that we just did. I will post some ideas that you could include in the classroom tomorrow. This would make an excellent communication question on a test. Course notes 20, 1 to 3 would be your best starting point, and then we'll go to the textbook. Page 10, 1 to 3, 6 to 9, and 11.